the Cursor hackathon a couple of months ago that was run by us. Any Cursor meetups or anything around those things. I should have brought stickers, but okay, we'll save that for another event. So outside of Cursor, I'm a CTO for a company called Neum AI. We build the data layer for electronics manufacturing. And we've been running it as a super lean operation of 2 people. So some of the things we're going to go over today are things that we use when we're working in production and building apps using AI tools. Just a show of hands and some perspective, how many of you are like super seasoned coders, like on top of like everything that's happening in the AI space? Like, how many of you would call yourself as one of those people? One. Okay. Sure. The reason I'm asking this is like if at any point you feel like this is stuff that you've heard, or this is like getting boring because you already know these things, tell me so I can like take it in another direction. Like we have a deck, we have like a demo, but the best way to do this would be to build something and show something that appeals to the most number of people in the room. So at any point you feel like this is getting too repetitive or things that everyone already knows, point that out. I also want to keep this interactive, so at any point you have questions, feel free to like just raise your hand and ask those questions instead of just waiting all the way till the end. And I'll still be around after the session if you have like any more questions that you want to go through. So without further ado, what are we covering today? We're going over what exactly are we trying to tackle when we look at AI code bases, what sort of a stack you should be looking at, how do you use this to build something that will be relevant, some advanced patterns and techniques that have emerged within AI coding in the last like month, 2 months, and then we'll try to wrap up, do some more Q&A formally at the end. So let's cut to like setting up some context around this, right? So let's say you're using Cursor or Claude Code or Codex or like any of these coding tools you might like, right? Great at writing AI code, amazing, right? But every time you're setting up a new chat or every time you're setting up a new project, you're kind of going over the same stuff. That like, I like a monorepo when I'm setting up something. I want to use like TypeScript a certain way. My file naming conventions need to be a certain way. I don't like using npm. I want to use bun for everything. Like you're having to like specify things every single time, and partly the reason is that any language model or any tool that you use don't necessarily come with memory that's built in. Doesn't understand what exactly is the kind of convention, toolkit, styling, preferences that you have, and doesn't understand the kind of apps or architecture that you're trying to build. And this starts becoming problematic because it affects the efficiency with AI can write code for you, but also it makes it harder for you to manage thousands of lines of code that are being generated by AI because you start losing control as more lines get written, right? Which obviously then means it's harder to debug, harder to like sort of figure out what's going on. So every single time when this happens, like obviously this creates problems. So which is why you hear from people that AI coding is like pretty bad, and AI coding is hard to use. But obviously that's not the case because simultaneously you also hear from like people who say that, hey, I shipped like 10,000 lines of code today. I shipped like another 5,000 yesterday. I was kind of in the same boat. Like I think this year alone I've shipped like I don't know 5-digit number of lines of code, which makes no sense, but somehow also makes sense. So the question here to ask is, how do you sort of make your AI work to your benefit, right? So before we sort of get to the techniques, again, just to like re-emphasize the problem, like when you don't have these structures or patterns in place, you find yourself reworking a lot of stuff. It might have happened to you guys when you use AI coding where, okay, you used Opus to write some code for you. Things didn't work. You ask Codex to help you fix it, and then Codex just goes and like starts writing more code or like starts removing a lot of code that actually worked because it felt like it needs to rework everything. And then you find yourself like getting stuck in, look, I'm having to do more work or I'm wasting more tokens trying to achieve the thing that should have been easier, more straightforward to achieve because you just wanted to fix like one feature or 2 features, right? So this is where we sort of start going away from just having good prompts, but you also want to engineer the kinds of agents that you're working on. And Dex talked about this where when you look at the context window that's available to the agents, That is the only thing that you can engineer to affect the quality of your output. So Dex was also the guy who coined the phrase context engineering, which is hard to believe, but it was only last year, like beginning of last year, right? So context engineering, I'm assuming people are familiar with context engineering in this room. Yes, no? Okay. Yes, right? But if you're not, then context engineering is deliberately structuring how you feed context to the AI. So you want to have documentation, you want to have context about the project you're building. You might want to be specific about the kind of user you're designing this for. So all of this helps the AI come up with conceptual answers around, okay, given all of this, what's the app or feature that I want to build? And currently, a lot of services or apps that you might use will try to abstract this away from you to make your life easy. You might see this in some kind of a plan mode, right? So if you use Cursor, Cursor has a plan mode. And the whole point of planning is to ask you a lot of questions where they can clarify your thinking, clarify the context, clarify how much and what you're trying to build before you start building. Same with Claude Code. Claude Code has a planning mode as well. But even if there's no planning mode, what you can do with agents is specify what you have and then just say, hey, before we write any code, can you ask me like 10 clarifying questions? And you work with the AI to make sure your plan is correct before you commit to the LLM being like, okay, cool, now go and like write code and like build my app for me. So that's all context engineering. In Cursor, you can do this a few ways. First one is at a project level, right? Where I want to specify rules. This is important because you might have multiple agents running multiple runs on the same code base. You don't want to be stuck in the same chat window while trying to build 20 features because the context window gets polluted, and at some point you will see your performance drop off a cliff. So how do you make sure that some context is shared amongst every chat that you start? The way you would do this is by setting up project rules. Within Cursor, you can do this with like .cursor/rules, where you can set up a file. Or there's a more common framework these days called agents.md. What agents.md look like, and you can see like every coding agent on the planet uses it. But the way it looks like would be you set up some discussion around, okay, what my dev environment is. So, what commands do you want to use? If you're using pnpm or bun or like anything else. If it's Python, maybe I want to use UV instead of using pip. Like whatever discussion you might want to have, like you put it in your agents file. What your testing instructions might look like, what your file naming conventions might look like, what your commit patterns might be, like anything that can run across different agents as they're working on your code base, this stays in agents.md. So this is something that's now a common format that works across all coding agents. Cursor also uses it, but in case you didn't want to use Cursor's rule system, you can use agentsmd. How many of you have not heard of agentsmd? Okay, cool. So hopefully this offers some context. One of the additional things that you can do with agentsmd is you don't need to just have rules that are project-wide. They can be focused on specific parts of your project. So let's say I have a Next.js project, right? I can have an agentsmd file that sits in the root, so that'll apply to the general project. But let's say I have APIs that I'm working on that are like very specific. That API folder can have its own agents.md file. And that can be just focused on, hey, if you're using Gemini's API or something, this is how you need to do things. So you offer context on that specific part of the code base. So this can be nested as deep as you want. The way the AI agents in all these coding services use the file is that the agents file that is closest to the part of the code that's being affected will be the agents file that is used. So if I use Cursor's agent to make changes to an API, and I have two agents files, one is for the project and one is in the APIs folder, the one in the APIs folder will be the file that will be preferred, which is great because then the specific rules that I have for the API itself will be put into place. Hopefully that makes some sense. We'll see more of this in examples as well. So if it's not clear, we'll go over it. Second part is commands, right? So a lot of coding with AI is repeated workflows, right? Like I want you to do documentation research. I want you to do, certain actions that take place one after the other. If I ask you to ship the code, I want you to run a test. After you've run the test, maybe you want to, write a commit, push the commit. Like you might have like 3 or 4 steps that are chained together, and you run them every single time. Well, the good thing is that in Cursor, you can set it up as a command. And what the command will do is you can chain those commands together. That, okay, I need you to do a bunch of things every time I ask you to run this command. It doesn't always have to be services that you run. Sometimes you might want to define this as just something that you want the agent to do before it pushes code. So an example of this is I have a command that I like using a lot, which is called dslop. And dslop is, as the name suggests, AI code will generate a lot of slop. I want to clean the slop before I push my repo out because I don't want like those 20 comments from Claude, like 30 markdown files that it writes for like every feature that's been documented. Like it's just a lot of junk that I don't want in my code base. So I'll use something like dslop. Like so I have it on like a slash command, and let me show you what dslop looks like. Rules. So dslop is basically this, right? So check the diff against main, remove all AI generated slop introduced. So extra comments, extra defensive checks, cast to get around type issues, any other style things. So this is not necessarily generating, like commands, but you're getting the AI to review its work. And this also can be super useful. You might have seen some analogs of this in terms of for like other AI agent companies. So Claude has this in the term of skills. So does Codex. How many of you have heard of skills on like Claude Code or OpenAI, Codex, or any of these? Most of you have not? Okay, one guy has. Okay. So skills kind of work similarly. So let's say, you use Claude to write, like to build you a nice like website. And then that website is purple in color, right? Like all vibe coded slop. Like how do you make sure that the apps that AI generates for you actually looks polished and presentable, right? So there's this front end design skill. So there's a skill called front end design, which if you look at it, it's again like just a markdown file, but a little bit more detailed where it says that like, the skill guides creation of distinct production grade front end interfaces before coding, understand the context and have an aesthetic direction. So this is kind of like pre-gamed prompts that you can use, but these come as skills. So if you use the same Opus model to generate web interfaces for you versus using it along with something like this, you'll see a huge difference in the quality of output that you get, which is the whole point, right? That how do you and I use the same tools and get better outputs or different outputs while trying to do the same things? This is where the difference comes from. So if you want to go and look at some of these things, so like Claude Code has them as skills. If you use Codex, we open up Codex. So in Codex, if you do /, you'll see skills creator and skills installer. You'll be able to like set up skills for Codex as well. So again, everyone is trying to do some version of this. Within Cursor, you can do this by using commands. So far, so good? We're feeling okay? Cool. Next step, hooks. One of the things you can do is you can also control what the agent does within Cursor. So maybe I wanted to not allow me to install random packages. Maybe I wanted to do something else. The thing is that with hooks, I can control exactly what the agent does, whether it needs to block things or whether it needs to activate things. We'll get into more of this later, but this gets into like how you can start customizing some of your coding environments for yourself. One of the examples for this is like a stop hook that Claude Code introduced recently. And it works here as well, with the intention being, how do you make sure that your coding agent does not stop, right? I don't want it to stop. I want it to keep writing code, keep going through all the to-dos till it's fully finished. So usually the problem is that the agent will just interrupt you and be like, hey, I just finished the first thing. Do you want to start the next to do? But I don't want you to stop till like everything is done. So one of the ways to get around it is to use a hook where, every time the agent loop finishes, you just trigger the next loop, which means that the loops can keep running as long as they need to. There is some new work around this as well, which we can go through towards the end of the presentation. If you've been terminally online on Twitter, you might have seen this week. More on that in a second. The last layer of the stack that helps you sort of with AI coding is tools. So as everyone knows, LLMs by themselves don't really have the capacity to do many things, right? Where the LLM starts becoming an agent is through a few methods. The first one is you've now provided it access to tools. So now Opus can go check the internet, right? Now it can read, write, create, delete files for me. These are all tools that I'm giving access to Opus. If I just use Opus in like a sandbox with no tools, it cannot do any of this, right? This running in a loop with tools and memory, short term or anything, is what makes it an agent instead of it just being a language model, right? But how do I add more superpowers or tools to my agent, right? Like I do not want to be stuck with just what Cursor allows my agent to do. So the way to do it is by connecting it to some kind of a connector or MCP. How many of you have never heard of MCPs? Okay, we're doing fine. So within Cursor, what you can do is you can just add MCPs for documentation search. If you want to steal front-end design kind of inspiration, you can add Firecrawl. So what Firecrawl will do is it'll go fetch the website, and then it'll fetch all the styling details. Oh, like this is the color scheme that the site uses. These are all the fonts the site uses, because it'll crawl the page, it'll go through the code, it'll study the CSS, and it'll pull out all the relevant information. So then when you're trying to replicate a website or copy a website, it's easier to copy design inspiration because the MCP server went and like crawled the site for you and came back with answers, right? So a combination of this starts offering more context to the AI, because if I have proper stylistic inspiration and then I ask my AI agent to build me an app, it'll do a good job. Even this presentation follows Cursor's design scheme. All I asked it to do was go to Cursor's website and like get the design scheme for me. So it found out, okay, like it likes oranges for like highlights, the background color, all those kind of things, right? Instead of me having to like guess or me just making a presentation randomly, this is how you can keep the stylistic inspiration. So again, that offers more context. Any questions up to this point? Yes.
So how do you do that? Do you just prompt like, can you look at Cursor's website, or do you need like a plugin or something?
Yeah, so that'll come through the MCP, right? So in let me just like close this agent thingy. Go away. Oops. Go away. Oh, she's still here. Damn it. Chat. Go away. Okay. So within this, right? So like you can add tools and MCPs to your Cursor agent. Not only in Cursor, again, you can do this with like Claude Code, Codex, all of them. The intention is that if I have an MCP server, you'll see that it has tools. So it can scrape a website, it can map like the sitemap, it can do search, it can crawl a website, and you can see what the description of each tool is when you hover over it. So the crawl says like start a crawl job on a website and extract content from its pages. So obviously Firecrawl's entire business model is allowing you to do these things, but now you can give your Cursor agent access to these things. So when you're building context for whatever feature or app you're trying to build, I can pass it a link and tell it to find content from that site. Now, obviously finding just the raw content is pretty easy because you can just search for these things. But where this starts getting interesting for me is when you use this to collect data on like design schemes, right? Like if I pass it a website, like if I could probably find the chat. Let me see if I can. Is it in this chat or somewhere else? I'm pretty sure that if I like look deeply enough in this plan somewhere, no, not this one. I think it was this one. Also, the slide deck was like vibe coded. So like, so yeah, you can see, right? So I sent, let's check out Cursor Home for design inspiration first. It went online. It found color schemes. It found the branding. So if I like go further, what font is being used? What are the fallback fonts being used? What are the color schemes? Right? So all I had to do was pass that. But if you just try to pass this information to an agent generally, like go to the website, it'll just go to the website, but it won't go deeper, right? This is where like a particular MCP helps me solve for that problem. This is how you can augment what your MCP can do. Now, let me give you like another example, right? Let me close this chat stuff. So this was Firecrawl, right? Have you heard of Context 7? Okay. Let's say you're building an app with, which is using a bunch of external libraries, right? The problem now is that LLMs have fixed training date cutoffs, right? Like the LLM was trained up to August of 2024, Jan of 2025. But like it's been 1.5 years. It's forever in the AI space. So there's so much new stuff that's come out, like, which is why, you try to build something with Gemini and the AI code will default to using Gemini 2. But Gemini 2 was like a year and a half ago, right? But you don't want that. You want your code to be up to scratch. Same with, let's say you were building something with OpenAI's GPT API. When GPT-5 came out, they moved from their existing API to this like responses API, which broke everything. So if you just tried to like swap the model names and hope that everything works, it did not. So how do you make sure that your AI is on top of the documentation? Well, there are a few ways. Back in the day, what you could do is you could add documentation to Cursor directly. So you would add documentation, it would index the documentation, you would remember it. But maybe I do not want to give it all the documentation. Maybe I want to be a bit more specific with what I'm doing. So the way to do that was to use Context 7. So what Context 7 does is I can search for a library and say, like, let me just show you, right? Let's start a new agent. So I can say, hey, I'm thinking of building an app with Vercel AI SDK 6. Can you check Context 7 MCP and tell me what's the easiest way to set up Gemini with it? Either directly or with the AI gateway. I'll go to ask mode because I don't want it to write code. So what Context 7 will do is, was being blocked. Oh, it's been blocked in ask mode. Oops, sorry. Let me just run this again. So what it'll do is, given that I mentioned AI SDK 6, it'll go look for documentation. So you can see that it found documentation for AI SDK 6. Now it's going to query it. Since I mentioned AI Gateway, it's also going to look for AI Gateway related documentation. And then based on all of that, it'll give me my options. But you can see that it defaulted to 2.5, right? So maybe I'll have to add more context and be like, hey, I want to use 3, use 3 for me. AI Gateway is what Vercel provides, so you don't need to configure your own AI models. You basically just pay them, and they provide you at cost. But yeah, so it was able to find documentation for me without me having to worry about whether my AI knows these things. And this is where Context 7 becomes really useful. It's also useful for like obscure libraries that I don't expect the AI agent to know out of the box. Because if you're working on Next.js or Convex or any of these things, there's enough training data. So your LLMs are pretty good at answering these questions. Like if you're building with Convex, for instance, and you ask Opus to solve for problems with Convex, it'll one-shot the requirements, like no real issues. Same with like Next.js. Like for the most part, it'll get it right. But if you're getting into like libraries or specific quirks of certain libraries, Context 7 does the job for me. And this usually performs better than just doing raw search, because sometimes if you look at the traces for how the AI agents are working, they'll be like, AI SDK 2024, and then they'll try to search, which again is outdated, right? We're in 2026. So that's how the MCPs sort of work. Hopefully that makes sense. Cool. Yeah, I mean, I also have like post hog. Like, I mean, if you like, I have like data I need to monitor from post hog, but post hog has like 40 something tools, which starts becoming real problematic. Yeah, it has like 47 tools. So you can do so much. So you can run like your entire post hog data set and manipulate it the way you want with all these tools that are available. The problem with all of this is that the more MCPs I have enabled, the more context window it starts taking, because I'm now adding more context to the AI agent, right? Like, I'm giving you access to 20 more tools that you can use to figure things out for me. This will change. Cursor only announced this like, I want to say 5 hours ago, 6 hours ago. So this is like pretty brand new. But what they're going to do is they're going to have a, where is it at? It's here. So they're going to do like dynamic context discovery. And one of the things they're going to do is, how do you efficiently load only the MCP tools you need? Because if I have post hog connected to my agent and I have 48 tools, my context window is already half full, maybe more, before I can even start the chat. But this will help avoid that situation pretty soon. Give it like a week or two. You'll see that like you'll use like nearly half the amount of tokens you were using previously. Yeah, so that was a bit of a tangent, but hopefully that explains how MCP servers and all fit. Next, so as I mentioned, all of these are built into Cursor, super easy to trigger. We'll go over like the others as we sort of go and build. So I was thinking that while we're here, we might as well try to build something together, because what's the point of me yapping if we don't really show any of this? So I was thinking we go build this app. I've never built with React Ink before, so this will also be new for me. But I was thinking that like we build a CLI dashboard where you can figure out like what your repository looks like, dependencies, that kind of stuff. So I'm going to set up a fresh project. Let's do a new window. Project. Where's my? We'll call it. What was it called? Quick check. Quick check. Okay. So we have quick check here. And quick check is supposed to be a CLI dashboard using Ink. So the first thing we discussed was, how do we set up a harness for our AI agent to work best, right? And what we discussed as the answer was having an agents.md file. So let's create that agents.md file. So what am I specifying in the agents file? Right now I'm specifying what the project overview is, what are we using, some code conventions. This will be useful so when the AI is building with it, it can use this as information. The other stuff we might want to add is some structure. So like, what files would you have, what the architecture might look like. So you might not want to get this detailed where you have like every single line drawn, but it might be important for you to describe, hey, I like keeping my API route separate, right? I do not want it under like a utility or like a hook or somewhere else. This is how I like my components to be designed. I want my component names to be kebab case instead of like camel case. So naming conventions, file placements, where is documentation? Do you want it to do more documentation as you go along? All of these things start becoming part of the agents.md file. So I can just copy that in. I can also just ask Opus to be like, I'll just save this. Oops. Save this and say in agent.md, can you add a section that covers testing using ytest, right? If you're not sure on how to write your own agents.md, just copy this site, pass it. This is a reference to write good agents.md files. So it'll have some like idea on, close this, right. So now you can see it's adding some more lines on how to run tests, what kind of testing conventions you might want to have. This is obviously very useful. Like I didn't have to come up with all of this on my own, but knowing what you want is probably more important than knowing how to get it. The AI will fill in the gaps for you. So this looks more comprehensive to me, so that if we build something, can we write tests and like check as we go along? Yes.
So you mentioned I can have like multiple agents on MD, right?
Yeah, yeah.
It will take the most like nested one, right?
Yes.
So like, is there any situation where I want to extend the nested one instead of like replace the whole file with the most like adjacent one? You know what I mean?
What do you mean?
So like if I have like a nested directory,
Yeah.
and instead of getting like the AI to just take the agents or MD in the nested directory, I wanted to just extend that file on top of like my main project file.
Yeah, it'll do both. So it depends on what you asked for, right? So like if I'm asking for, let's say in my APIs directory I have an agents.md file, and I'm asking for changes made to the API, it'll prefer the nested agents file. But if I'm asking for like a project-wide change, it'll prefer the one outside.
Okay.
Right? So that's why I can have multiple files, and then the agent can figure out which one is.
So it won't, if I'm in the API file, it won't forget like that I had an agent.
No, it won't.
Okay.
It won't. So like even on the official documentation, you can find the, right? So large mono repo use nested agents. So place another agents file inside each package. Agents automatically read the nearest file. So the closest one takes precedence, and each sub-project can ship tailored instructions. So OpenAI's repo has 88 files. So if you wanted to go check this out, like Codex's repo is public, and in this you could find like agents file that runs like overall, but then they have more. So what does their agents file look like? Because they're writing in Rust, they have a lot of documentation around how to do Rust. There are a lot of links. So if you have references, so for example, let's say if I'm building in TypeScript and I do not want to use useEffect because useEffect's like messing up my app, I could pass it, you do not need effect. I will take this article, which says you might not need an effect, and I'll pass it as context. So then the AI agent knows not to randomly just throw use effects all over my project and just make it super clunky. Right? So you can add links, you can add references. Okay, not this one, right? But you'll see they have like, because Codex is also terminal based, they have like style conventions, code conventions, styling, text wrapping, specific tests. You can get like pretty detailed with this. We're obviously using a very simple example, but if you wanted to use the agents file in like depth, you totally could, and it would do the job. It's also easy to check this if you go to Cursor's settings. So if you go to rules, you'll see that there are a few things that are available here. The first thing that's available is agent skills. So you remember earlier we discussed the idea of skills, like the front-end design skill and all those things. You can use those skills interchangeably in Cursor. So if you want to use Cursor to do better front-end design, you can either define it as a command or you can just get that Claude skill downloaded and use that, right? I have some of my own rules, like don't give me high-level shit, because like this is how Cursor used to be in like, 2024. So like I've had these rules since. But then you'll see, okay, project level rules, if you want to add, always applied. So these rules are always included in every agent conversation, the agents.md. Yeah.
I mean, like, so if I'm reading 10,000 lines of code a day,
Yeah.
how do you keep up with like reading that much code? Because even reading like 200 lines of code at once is so difficult.
Okay, I think if we have time left, which I feel we will, I'll take you through something that's helped me a lot with this. This is again like, my friend was building this like middle of last year, but somehow it's only gone viral like in the last week. So I built something for that, and I'll take you through like my thinking of how that works to like extend this. So hold on to that. But yeah, okay. Agents.md, agent can decide when to fish the rules. So you can see Codex rules, front-end design rules, Stripe best practices. So it already has like some Claude plugins and stuff because I have Claude also installed in my system. So it remembers which skills it can use. So you can also add your own skills and augment what your agent's doing. Commands was something we discussed earlier. We're going to work on adding our own command as well. A couple of commands that I always keep in my projects, like across, are dslop because I do not want AI slop. And second is explore. That sometimes if I have a GitHub repository that I want my agent to reference, what you'll notice it is A, it might stop reading at the README level, or B, it'll do a shallow clone where it only gets like one level deep and say, okay, this is what the repository is. But I want the full repository. I want like the full action. Like if I'm trying to port, let's say a Python repository to TypeScript, I need you to be like reading the entire repository, not just like 10 files and calling it a day. So what Explorer allows you to do is you clone the entire repository into a temp directory, and then you read that temp directory, which always works better than just giving it the repo and asking it, hey, go online and like see what happens. So I always have these two defined as additional user commands, but you can add more. And you can always add sub-agents to Cursor as well. I don't use this as much, but if you have like specific things like agents for CI/CD or anything that you might want to define, you could just define through the settings. Okay, let's go back to this. So we have like our agents MD file set up at this point. Now what we want to do is set up the project. I'm just going to copy this shamelessly. This looks fine. Just start a new chat. I'll start this in plan mode. Plan mode is with Shift and Tab. The reason being, I wanted to go over some Q&A with me before it starts building stuff. One of the things that like the new models have done, which is really good, is you don't have to obsessively build each feature one at a time, right? You can build massive to-do lists with like 10, 20, 30 features. The challenge usually is how well scoped out these features are, because if they're poorly scoped, then like it doesn't work, right? It'll fuck up all 10 features. The other thing is, how do you manage context to make sure it can build all those 10 features for you, which is what his question was. And we'll have an answer for that like later today. But those are like the two main issues. But we can start with this and see what it does. Plug this back in. It's reading the agent's MD file. It's going to build a plan. Now, I don't know if these are like the latest ways to do things, but what I will ask it to do is, can you double check the implementation using context 7 MCP for the various libraries? Also make sure we are using the latest versions of these libraries. In Cursor, you can see how much context you've used and what rule or what is being applied to your context. So you can see the agents.md is being applied. If I had like specific rules that I can pick and choose, I can also apply those. So let's see what it does. Okay, so yeah, so now you can see that all the version numbers got bumped up because it was using all the old versions. So Inc 6.6 is going to be used instead of V5. You know, React 19 is going to be used instead of 18. So you can keep iterating on your plans. You don't have to commit to the first thing that AI tells you, which is where like your job as engineers or designers or like technically light people come in, where you work with the plan. Make sure you are on top of the plan and you understand everything. If you don't, just keep asking questions. You don't have to commit to building anything till you are happy with it. right? So which is what we're doing right now. I'm just going to keep asking it to like change the plan here and there. So you can see the plan got updated, which is okay. Just changing some new patterns and stuff that can be examples to use. Yeah, so you can see verified from docs. It's added a lot more documentation and code examples for us, which previously were not there in the plan. This is good because now when Opus writes code for me, it'll use the actual patterns that the library suggests instead of making shit up and then like, nothing works and then I'm finding it hard to debug. The plan is ready, fine, go build. We have a nice to-do list. It'll work and like it'll build these things. Obviously, like we could have had like a bunch of like other prompts that we can add as well. So what we'll do is once this finishes setting up the dashboard part, I'm going to throw all of these into a plan and then see how can we iterate and build the next thing. Ideally, if this part is set up correctly, this should work the first time around, because that's the whole point of planning, getting documentation reference, adding more context to the agent with both the testing that I asked it to do, but also with using actual code references to build context. So far so good. Are we feeling okay? Questions at this point? Yes?
I'm more curious of the cost of a one run.
Oh, right now I'm paying a lot because I have busted through my monthly Ultra. So, but actually, I can check. I mean, it's not going to be that expensive, to be honest. Let's see. You guys get to see the.
How much is Ultra?
I mean, I get free Ultra, but I also have like a shit ton of credits. So I'm not a good reference, but you can see that like a $200 plan gives you about $500. But I also burnt everything on like an Opus High thinking. Like, you don't have to. You can be more judicious. But my on-demand usage has been off the chains because of the thing that I've been building that I just mentioned to the gentleman at the back. But you can see there's like 7 cents a request, and I'm putting in like a lot of requests. Like this yesterday, let me find the repository for you because now I'm like. Open recent scheme gen. So scheme gen worked on, if I open the Ralph task, it worked on only 17 phases of code. Like this is everything it worked on in like a single run. The commit history is here. This was one run. This ran like last night. So this is where I'm spending money basically. This was like about 100 commits, something like that. And this works by the way. But the way to do this is something I'll get to in a second. Okay, I guess it's done building. Let's see. To do, move, okay. Done, project is set up, npm dev, run the CLI, build, run Vitest. Now, ideally, if your agent is like set up to be a bit more autonomous, it should run the npm test for you, right? It should do some of this work for you instead of me doing it. But you can see that it did run the test for us because it was part of our agent description, right? That run the test. So it ran the test for us. So what am I supposed to do now? So it says that we should npm dev this. So let's go do that. I don't even know what to expect. So I'm also curious to see what we get. Cool. So we have a CLI tool. So we have dependencies, essentials, and 3 to-dos. Whatever that means. We'll have to figure that out. But at least our CLI is working. No errors, no issues, right? So you're able to one-shot a lot of stuff without the overhangs of, will things work, will things compile or not. Things are great. So what I'm going to do is I'm going to ask the agent, okay, great, this worked. This is the output I get. What are these to-dos? Or is this dummy text for now? And I also put don't write code yet if I'm just trying to have a conversation, because, okay, so it is dummy placeholder text. So actual checks are stubs that don't do anything real, which is fine, because all we had asked for at the beginning was just to set up a dashboard. We didn't really ask it to build any of these features, so obviously these features don't exist, right? The check implementation is also stubs. That's the actual work to build out. Cool. Let's go build the other features. I'm just going to copy all of this. I'm going to go set up a new plan. Build me these features. So while this is going on, one of the things to now think about is, obviously code gen works, but how do you do code reviews, right? How do you make sure that cursor is on top of what you're doing? Okay, for the dependency check, how should we detect outdated packages? Yeah, we can just query the, registry. So one of the options you have here is a debug mode. And what the debug mode will do in Cursor is actually write more tests and try to break your app to figure out where exactly your app is failing. Pretty useful if you want to stick to the same models and same workflow. Sometimes for debug, I'll either use that or I will use Codex and ask Codex to fix things for me. Might be slower, but works better. It's okay. So we have new stuff. So we're going to have dashboards with loading states, dependency checks, file checks, to-do counter. We got a nice mermaid diagram that I can't read because dark mode. Looks good. Gonna go build it. But yeah, I mean this process of working iteratively allows you to obviously sense check what you're doing, keep testing along the way, or get the AI to write tests and test along the way, and then make sure whatever you're building is what you want. And this is usually the workflow when you're using something like Cursor, where you've engineered context enough for it to know what you want to do. While this is going on, let's see, what's next? Okay, we'll get to reusable workflows next while this is set up. So let's say this finishes building and it works and things are okay. The next step would be, okay, how do I make sure I'm committing often, making sure that my tests are always running, and instead of having to write the command 10 times every single time, can I just have it as a trigger that does this for us, right? So I can use a slash command to ship it. And what the command will literally do is you force it to run all tests, update the version in package.json, so you have a version 1, 1.0.1, 1.0.2, whatever, right? Have change logs, so you have a change log document, so you can have everything set up there. Create a commit, create a tag, provide instructions for publishing. This is useful because I have to do this every single time when I'm working in prod, right? I have this npm library I built day before, and every time I make changes, I need to keep bumping the package numbers, the change log, and everything, because that's how npm will publish the latest version. So instead of me having to manually do these things in 3-4 files, I would ask the agent to do it. Problem is, I need to keep asking the agent, hey, change the change log, change the package file. Maybe it'll forget. Maybe it'll push to GitHub and miss both of them. So you want to kind of avoid situations like these. So, oh, it finished building already. Cool. Let's see. Let's see what it did. Cool, so we have one outdated dependency. So this is working, right? Now it's able to ask npm registry, get feedback, and make sure it works. So this was a very brain-dead way of building an app using 2 plans with 0 bugs in a library that I had never used. and I'm not sure if the LLM knew either. So all we did was pass some context around, give some documentation, let it cook. I can get more specific, obviously, about like what else do I want to see, what features I want to build. Let's build a to-do feature, right? So let's go to this. I want to implement the to-do feature. Ideally, I have a to-do.md in the root of the project, and when I run the quick check app, it is able to pull up the to-dos. So because we're in plan mode, it'll ask you questions. If you're not in plan mode and doing this, the easiest way to do this is just be like, don't write any code yet. Ask me clarifying questions before we proceed. Just to force the AI to like build its own context for you. So the to-do check read from to-do MD instead of scanning source files are both. Let's do both. What format do you use? Let's do GitHub style checkboxes. Continue. How should the results be displayed? So right now it's looking at the code to-dos, but maybe I want feature to-dos, so I'll say 2 dashboard rows and just have them separate. Because sometimes you might have like features that just say to-do, and that's what it's counting right now. But maybe I want like a feature list that's separate. What I'll also ask it to do is, can you also create a sample to.md file for us as part of the implementation? Okay, so now it's added a sample file. Go Opus build. So while it's building, I want to go back to the workflow. So obviously I want to use this. So what I'm going to do is I'm going to add this to my cursor. The easiest way to do this is there are deep links in cursor now. It'll say add to home or add to project. I'll say add to project. And now we have a ship command. So if I go to a new chat and go /ship, you'll see that the command is available. So when I run ship after we finish building it, it can just run ship for me. Or if I want to deslop or whatever. The good thing is that you can create these commands. The easiest way to do them is through deep links in cursor. So if you look for cursor deep links, what deep links allow you to do is either take prompts or these commands, and you can create a deep link. So if you have something that you use that you want your friends to use or run every time, instead of having to repeat yourself or copy paste the prompts, you can just create a deep link which will automatically install in cursor. So now if I go here, cursor commands has a ship file which has my command, right? Okay, let's see, where did we get here? Okay, this is done, and now we have a to-do list. So cool, he even built project to-dos for me, which is crazy. So let's try this again. So you can see that now it says code to-dos. There are 14 to-dos in the code, and to-do.md has 5 incomplete and 7 done, which is true because we have 5 incomplete, right? So we're able to very quickly iterate and build something in like an unfamiliar library with no errors. But a large part of this is how well you scaffold your AI agent to execute for you, and which is where planning is super, super, super important. Any questions at this point?
Just curious, like, how long can you run without like human intervention?
So the cursor agent by itself will always interrupt at some point. So I built something that allows you to run indefinitely, which is why, again, this is all sort of going to the same direction. So hold on to that. Like, we'll go over that technique. Because even if you use Codex and stuff, so previously what I used to do was I would queue up like 30 continues. So it would run one task, then once it thinks it's done, I would say continue, and it would start the next thing. And it would say, hey, I finished task number 2. It will immediately just keep triggering continue, and it would run like continue like 30 times in a row, so it could do at least 30 features. Then that's when like people started coming up with like stop hook. So in Claude Code, you can write a stop hook that allows you to just run the output, and then you can create a continuous workflow because you can like keep sort of going to the next thing. There is a problem with it, which is if I just keep going within the same chat window again and again and again, then me running an agent for like 2-3 hours is actually counterproductive, because my context window is going to be full, the quality of output is going to be bad, and like obviously that doesn't make any sense, right? You ran for 3 hours and only the first 30 minutes were useful, and then you're like undoing a lot of work. So that becomes a issue of how do you free up your context as you go along, and we will get to that in a second, right? Okay, so let's try this ship command we just came up with. Now that like this looks reasonably okay, I can first do deslop, so I can get it to deslop my code. Ideal, especially if you're working with other people, that you don't want to have like all the Claude emojis and like 30 markdown files and stuff. Keep cleaning your code as you go. Life will be easier. So like it'll read all the files. So you can see it found some unnecessary comments. Try catch blocks. So let's look at the thought process that it had, right? So it said looking for slop in the code. JS.comments. So we asked for JS.comments. So these are required, but some of the comments are a bit verbose. So it checked these are fine, this is reasonable. Unnecessary comments. This is obvious from the code, you can remove this. Somewhat obvious, this is actually useful. So this becomes useful that if I'm going to leave comments, I don't want to just leave like 200 comments, like leave actually useful comments. It does all the cleanup, so now I feel good about having cleaner code that's available to me, which is useful. Everything works, cool. Okay, I'm just going to initialize a Git repository in this just for the vibes. And let's do ship. Let's see what ship does. So it'll create, firstly it'll run tests, because we asked it to run tests as part of the shipping. So run all tests. Then it knew that like the tests are not passing because there are no tests. So we should do something about it. This would be something for us to look at. So you can see test failed. Second is it upped the version number, because the version number needs to go up. It now has a change log. The CLI version is going up. And now it's creating the commit and tag. So instead of me having to do things manually, I just have one command firing and like doing things for me. Release is ready. Cool. If I go and check, I have a commit here. Chore release with dependencies, blah, blah, blah. Right? So highly encourage you guys to like use the deep links, because they're super useful to set these things up. And as you can see, once you do this like version bump and stuff, this becomes really easy for you to publish to NPM if you're building your own libraries, because they're super picky about your version numbers, update logs, these kind of things. Okay, let's look at the next thing. So next thing is lifecycle automation. So we briefly talked about hooks earlier in the session, but we were talking about how can you control the cursor agent to do things for you. And What hooks allow you to do is you can intercept the AI actions and add some kind of guardrails. You might be able to do things like after you finish editing a file, do something. Before an MCP executes, do something. Before you read a file, do something. Or, if an agent has done 3 tasks, stop. So you can stop the agent from continuing and like actively trying to fill up its context window. So what we can do is, it's very easy to set this up. You create a hooks.json. We'll do that now. Let's go to cursor, hooks.json. And I'll paste that in. We'll have to create the hook as well, obviously, so we can do that. So what this hook is supposed to do is, again, you can get AI to write this hook for you. You don't need to worry about it. But the way to think about this hook is hooks. Is it in hooks, right? Yeah. And security dash check.sh. So, oops. Sorry. All right. So you can get like AI to write this for you as well, but the intention here is how do I prevent my AI agent from doing things that it shouldn't be doing? So in this case, is blocking vulnerable packages. In this case, we're only trying to block these packages: event stream, flat map stream, left pad, whatever, right? So if I try running this in our agent, let's go to, I think I might need to refresh the coding environment. So let me just like quit and come back to it. Oops, where are you, my guy? Stop hanging on me. Okay, cursor hooks are here. Let's go see whether the hook truly works. Let's see what this does. Oh, it did install it, so maybe we didn't set it up correctly. Okay, so I'm just going to ask it to remove this again. So remove the package. Can you check whether our hooks in this file are correctly placed in the repo? We have security check that we want to call. Yeah, the reference is the wrong place. Okay, cool. Let's try the thing again. Okay, so you see this here now, right? So command rejected, blocked due to vulnerability. So you can set up hooks within your code base, especially if you're getting into like more production kind of stuff, where you can restrict the agent's behavior, you can augment the agent's behavior, you can make it do more things, you can make the agentic loop much more customizable to your needs as opposed to just relying on what Cursor gives you or what Claude Code gives you or Codex gives you. So this is a pretty neat way to do this. There are a bunch of hooks that are available. So if I look at Cursor hooks online, with hooks you can like run formatters, adding analytics, scanning for PII, anything that's getting exposed, gate risky operations. So you can control a lot of stuff within the agent. You can track agent responses. So maybe if you've had a long conversation with like 5 turns or whatever, you can be like, okay, kill the agent, like no more. But you can basically control the quality of your output from the agent with using hooks. Okay, the last part, which we kind of covered at the beginning, was MCPs. As we mentioned earlier, MCPs are a great way to augment what your AI agents can do, not just within the app, but any AI apps that you build. The easiest way to find MCPs is you can usually search for the companies that are offering it, but one of our friends built this site called Smithery.ai, where you can find MCPs that can extend the application. So let's say I wanted to add GitHub's MCP. I can just press this and I can install to Cursor or whatever. But because there's like an address that's available, if I was building an AI application of my own, I could connect an MCP to it. Where would you use an MCP in your applications? Why can't I just use an API? Good question. You can use an API, it's probably faster to do it. But sometimes if you want to, again, engineer context for your AI agents, the easiest way to do this is with an MCP. So I'll give you an example. I use this app called Poke. And Poke is supposed to be one of those like AI personal assistant thingies that can like read my emails, calendar. It has like basically keeps my life in order. But one of the things I wanted to add to it was something to track when the buses are coming so I can plan my travel if I'm going for things. When should I go take the bus? Now, obviously, Singapore has an API for bus routes. Like, this is not news. But the problem is that it's hard to get an AI agent, especially one that is not yours, to execute APIs on your behalf. But you can usually give them access to a secure MCP server that could be either authenticated by you or otherwise, and get them to use that as context. So what I did was I built an MCP server for it, which sits here. Like all the server is doing is it's like pulling out 4 tools. So if I ask my Poke agent, hey, what time is the bus gonna arrive at like this bus stop? It'll call this tool and it can use that to inform context. What this also means is I can connect this MCP to Cursor and get Cursor to tell me when my bus is coming. Like, does it have any value? Probably not, but like it's just fun. Sometimes you just do fun things. So Smithery is a good place to start looking for MCPs. Like if you wanted to add, let's say anything you do on Cursor, you want to document a Notion. How do you connect Cursor and Notion? You can connect Cursor and Notion through an MCP. So it can literally just write to your Notion workspace directly. Let's say if you were using Supabase and you wanted to have a read on your database, instead of you having to do migrations manually, wouldn't it be nice if the Cursor agent could do that on your behalf? Where it can read the schema and the structure of your data and then design the front end with that in reference. Or it understands what tables you have so it's not making up table names. Like these are the kind of contextual things where if you're working with a database or something, you get these things wrong, your app doesn't work. So the easiest way to get around it is you use Supabase's MCP. And what that allows you to do is, so they have an official MCP. You can see what organizations you're a part of, what projects you have, get that project. Then once you have that, you can You can also create projects. So let's say I was just in Cursor and I said, hey, I want to spin up a new Superbase project to like build my app. Instead of me fiddling around on the dashboard, building an app, getting keys, configuring the keys, doing all that yucky shit, I can just ask the Cursor agent to do it for me if this MCP is available to it. So that's how you extend the capabilities of whatever agents you're using. If you're building any AI apps of your own, you can also do this. Like if you use Vercel AI SDK, which is a nice way to wrap all the different AI APIs from like different providers, because you just have the same code and you just keep swapping the models around. Like if you wanted to swap Anthropic to Gemini, you just change this line in the model and that's it. The rest of your code stays the same, which obviously makes life easier. So one of the things that allows you to do is you can add MCPs to it. So if I have an application, I can add MCP capabilities to AI SDK. So AI SDK MCP. Yeah, you can set up an MCP client of your own if you want to, but also if you're building an AI application that needs to use an MCP, you can add an MCP to it. So let's say in this case, you had an MCP that tells you the weather. I provide that as an MCP to my Claude model. Claude can then go figure out what the weather is. Could this just be a tool? Of course, it could be a tool. The MCP just has many tools instead of being one-to-one. That's the only difference. Okay, where are we at next? So we discussed MCPs. Examples we gave. You can use a lot of MCPs that are super useful. I really like Exa as well. Exa is search but better. So this does a really good job at both within AI applications that you might build, but also if I want to add search capabilities to any agent, I really prefer using Exa. Their free tier is, I think I might still be on the free tier. Like it is like so ridiculous. So you can search for stuff, you can find answers, you get a very nice structured way of getting this that is compliant with any OpenAI API style. You can get references, you can do research if you want to do long research stuff, crawl pages. But now imagine this capability built into Cursor or Claude or whatever, right? You can just do so much more with the same agent that you weren't able to. I'll give one more example before proceeding. So a few of my Twitter friends have been building a personal assistant with Claude. And how this works is using a bunch of these different MCPs and tools, you can build your personal bot that works on WhatsApp, Discord, Telegram, wherever, and you can connect it to whatever you want, basically. People have like a grocery autopilot, you can get order histories, rail planning, memory vault for WhatsApp, phone bridge, Google Docs editing. So imagine I'm editing Google Docs through like Telegram or like Discord or something. But this is like one singular agent that is able to do so much. The only way it's able to do so much is through integrations, right? So this is like a good framework to think about how do you extend AI applications. Okay, what do we have next? Okay, now we're getting into the fun stuff. When we work in Cursor, you will see that we have a context window that we're operating with. The challenge is that once this context window starts getting like past 60%, it starts getting into dangerous territory. Not so much that it'll harm you or whatever, but more in the sense that the quality of what the AI is going to give you as a response starts dropping. Which also makes sense, right? Like if you and I are having a conversation and we've been talking to each other for 2 hours, I do not expect you to remember what happened in the first hour. Like you will forget, right? You will either forget, or if you don't forget, you now are just juggling so much more information that it's harder for you to pick out what was important at the time when I asked you for some other detail. And both of them are harmful when you're writing code, because if you just forgot specifications I gave you, then the code's going to be wrong. But if you misremembered what I talked about, or you missed context on what I talked about, then also what you generate for me is going to be wrong. So what you want to do is you want to keep compacting what you're doing. You either research, plan, and implement, so you build singular features or singular sets of features, which is what we did for our example, where we just planned 3-4 features, build it at one go, finish it. We start new chat windows so we can make sure that context windows are fresh. You can also save learnings from what features you've built into a document so that AI can just reference that document instead of having to, let me read the entire code base again and then figure out what's the part that I need to work on, right? Because if the agent is having to read the code base every single time, then you're still going to burn a lot of context, right? The last thing that I haven't put on the slide, but obviously matters, is sometimes your context might have the wrong answers. Like let's say you've had a conversation with the AI. AI built something. You were like, no, I did not want this. I wanted something else. This happens a few times in a conversation. Now your context also has wrong, irrelevant information that starts affecting what subsequent steps look like. There was a paper that came out sometime in like May of like last year, where they were studying what happens to AI, like to LLMs, which have wrong answers in their context window. And that time, like O3 was the smartest model that was out there. And O3's performance went from like 95, 96% to 60%, just because the context window had wrong answers embedded in it. So therefore, it starts becoming really important that whatever is in the agent context is important. Which is why, if you're here and doing things, let's say, let me try to find a previous chat, right? Project setup. Like I can go back and restore a checkpoint and fork my conversation, because maybe I do not want the wrong stuff that happened since. Like assume that after to do MD, everything we did was wrong. I could keep trying to correct the AI. Be like, hey, fix those like 10 features you built. They're all wrong, whatever. But I'm confusing it further because it already built these 10 features that it thinks were correct. So I'm better off just resetting the conversation at that point, refreshing or resetting the context, and starting over. And that makes life significantly easier in terms of the quality of output you get, right? So there's something to think about when you're going to like use AI to write more code. Complex refactoring, we discussed the shift tab is how you start plan mode. That's super useful again, as you've seen with the examples. If you want to obviously expand these applications, as I mentioned, Vercel's AI SDK is good, Gemini is good. So for the application we were building just now with the command line, we could extend it to use AI to find alternative packages or like some other random shit, or like analyze the code base and like give additional details beyond just looking at packages. For that, I could just include any of these features, but the process will be the same. I would use the plan mode. I would tell it, hey, I want to extend this feature. This is what we have. This is what I want. This is the library to use. Use context 7 MCP or like anything to get documentation. You good? Okay. Get documentation. And then once you have all of that, let it go and build. And that's like the most foolproof way of building stuff, especially when you're building more serious apps or like production apps. Configuration conversation. So again, the more context you can set up that's great. The more context that you don't have to set up again and again is even better. So if you have an agents.md file that you can use across projects, you should do that, right? And make that more comprehensive, where it has rules for Python or maybe TypeScript, Rust, depending on whatever stacks you move with. More general thinking around, hey, maybe you should not commit or push anything to GitHub unless I expressly ask you to. Because sometimes the agents might get too eager and start committing things to prod when you never ask them to. Maybe you want to ask the agent to only work on work trees and branches instead of working on the main branch. Like these are the kinds of things that you can have set up and ready to go. And you only need to set this up once, because if it's in your main agents.md file, that's the only time you need to set this up. Next thing about Cursor's agent stack, it's pretty comprehensive in terms of rules, commands, hooks, and MCPs working together. But regardless of your allegiance to any tool, whatever tool you want to use, keep in mind that you will need some version of this for it to shine. You will need some kind of a skill, like the Claude Code skills that I talked about, to get great output. Like that's the difference between, two people being like, hey, I use the same prompts, I use the same tools. How is my shit so garbage and yours looks like so good? Like this is literally the only difference. Context is everything. Couldn't repeat this more. Start small. Add an agents MD file today. Keep building upon it. Maybe start with like a project. Maybe start with a feature. Start small, but like keep building on top of it, and you'll start seeing the benefits like pretty quickly. Documentation or whatever. Okay, so before we get to questions, now let's get to like the meat and potatoes of like some of the questions that were asked earlier. If I want to run a task or like an agent in basically an infinite loop for it to run through 100 to-dos without busting its memory or context while being correct, like how do I do that? Right? Because like currently we are stuck with, the agents that are given to us. The agent context window fills up. They try to summarize on their own, which may or may not be a good thing. And then based on that, we kind of figure out what happens. But the most like useless part of all of this is that I need to be involved in the process where I'm having to like say, okay, let's build the next feature. So one of my friends, his name is Jeff Huntley, earlier in the year came up with this thing called Ralph. Like how many of you have heard of Ralph Wiggum from The Simpsons? Anyone? No one watches The Simpsons in this room. Okay, one guy. Has anyone heard of Ralph in context of AI? One guy, 2, 3. Okay, cool. So Ralph was Jeff's attempt at doing this stuff, and he was doing this in like July, which is early. So his deal was that if we put a coding agent in a while loop and just let it run till it finishes all the tasks, wouldn't that be great? Wouldn't that be great if we can just get the agent to run in a loop, keep working on its to-dos till it finishes? Life would be great. Problem is, so you can use this with any tool that does not cap tool calls and usage, right? So the only limitation is how much money you want to spend, right? So if you have like Claude credits, let's say on a Claude Max plan or like the $200 a month plan, right? You could run this for a while, like till your daily cap needs to reset or whatever. But the question then is, how do we do this, right? Like what's the methodology behind it? And there are a few things that are like super important. And I'll show you how I use Ralph as well. Firstly, I'll make life easy for you guys by just giving you access to my version of Ralph if you guys want it. It's at Ralph Wiggum Cursor on GitHub. The problem to note here is the malloc free problem, which is if I'm using an AI agent, the AI agent obviously has all the files, all the stuff in context, right? It keeps working. You have already allocated to memory and context what you want to do. How do you free up context, right? Now, with AI agents, you can't selectively delete things from context. Because if you selectively delete stuff, then you don't know what is the correct stuff in context, and then it may or may not work as you go forward. So allocating memory is really easy. Releasing memory is hard. So every time I read a file, I use a tool to create a file, read a file, delete a file, whatever. Every time I start a conversation, I keep adding to the context. But there is no way to empty the context, right? The only way to empty a context is I start a new chat, which makes sense, right? So if I'm in Cursor, I start a new chat every time I want to work on a feature or a set of features because this number will reset. So I kind of want to do the same thing. But if I'm not able to do this, it creates a problem where your context has everything that went wrong, all the code that was irrelevant to the feature you're now building because you built some other features at the beginning, and everything starts confusing the model. The other stuff is like you have a gutter now. Like everything that polluted your context is sitting there, so the model will keep referencing this. And you can't save your model at that point because it'll reference the files it references. Unless you are like super hardcore about like guardrailing your AI, but like that's more work than necessary. So the easiest solution here is I want to make sure I keep rotating the context. So there's always a fresh context window after a period of time. The other thing is that instead of keeping the state of what my project looks like in the context window, I want to keep offloading it to files or to GitHub so that there's always a reference to what the state of the project is, and that sits outside of the context window, not in the context window. So all the context window's job is to just execute during that period. So the way I have it set up is pretty simple. I have an activity log that tracks all the tool calls that are being made. Let me find a repository that I did this with. So you have, not this one. SchemeGen is a good example. So this is the repository I worked on yesterday. So you'll see that like every tool call is being logged here. Session started, which file was read, how many lines were read, how many tokens are being used. At some point, you'll see that when it's used up a fair amount of tokens, like we were getting to about 50, 60,000 tokens, it starts committing to GitHub. It'll start writing commits, documenting what was completed. Once it finishes that set of tasks and pushes to GitHub, it starts a new agent. So it automatically keeps handing off to a new agent, which can pick up where it left off and then continue building. So you can see the session starts, it will read the guardrails, the task list, the progress, and the errors. So what are these files? So I have errors like, let's say an AI agent gets stuck doing something 3 times. It'll go in the error log so that AI has notes on, hey, I've been like screwing this up again and again. So when the next AI agent picks it up, it does not also make the mistake 3 times to realize that this will not work. You only need to make that mistake once. So you get it in error log, but in the guardrails, it starts adding it under learned signs that, okay, I have learned that this thing doesn't work. So I should not keep doing this. So you have some core signs, that like read before writing, test after changes, commit checkpoints, usual guardrails. You can add more, but you also want to make sure your error logs keep getting added here so that it doesn't make mistakes. Activity log is the one I showed you. At some point, it starts getting red where like the tokens are getting close to 80,000. You might be wondering, why is this at 80,000? Like, surely context windows are bigger. But that's precisely the point. Like, Claude might give you about 160,000 in tokens, but I do not want to hit 160,000 because past 50%, things start getting into weird territory. So I artificially cap my agent's context window to 80,000. So when it gets to 80,000, it's still writing great code, but it just keeps committing and handing it off to the next agent. It's not costing me to spin up a new agent. In fact, it might be cheaper for me to spin up a new agent. And this is something you guys can test as well, that run an agent which has had like 30, 40 like features in one conversation versus you cycling through different features. You can do this in V0 and like a few other apps as well. You will see that the cost per message is actually cheaper in fresh conversations. The cost actually goes up in conversations that have been going on for too long. So this is also cost effective while also being expensive because I'm running this like on an entire repo. But you can see that like it writes very nice git commit messages. Once it starts getting close to the commit, to the token limit, rotation is imminent. It'll do a test, it'll do a commit again. And once it knows that like, yeah, I'm getting like real close, it touched 80,000, it immediately spun up a new agent and it continued work from there, right? Progress is where it records every single thing that it's doing. So how many iterations has it worked? What did it do in that session? What MVP criteria was finished? Next session starts. What did it do? So now all I need to do is my agent only needs to see this when it's picking up the next feature to build. It does not need to keep reading the entire code base because I've made its life easy in terms of, hey dude, like I've already done this part. Like just reference this. The other thing it needs to reference is a task list. So I have a Ralph task list where I have like decisions, goals, scope, whatever. This is the document that I spend the most time on because this is where I have like, what files do I want to build? What integrations I want to think of, what schema should look like, and then like the what are you building in each phase, right? Like, and this goes on like for a while, right? What kind of unit test should it be looking for? Um, Again, AI helped me write this. Like I have a template, so it just helped me fill in the blanks based on what I asked for. But this is literally the only thing I start my Ralph loop with, and this is more than enough. And once this runs in a loop with this setup, you can start a new agent with a fresh context window, which means I can keep running this forever, right? Till all my tasks are finished. Um, what the Cursor CLI allows you to do that you can't do in like Cursor's IDE is you can track the exact token spent. So which is why I built this for the CLI, because I can track, oh, I've burnt like 1,000 tokens doing this, or I've spent like another 200 tokens reading this file or whatever. So this makes life easy for me in terms of tracking. I could also track cost. So right now we're tracking it purely on tokens. You could also put a cost cap if you wanted to, right? Like, hey, the moment I've spent like $50, like stop, right? So whatever I built in $50 is what I built. But again, you can extend the Cursor CLI to do all of these things for you, which is great. Once you set it up, you have a bunch of these shell scripts that run. You define a task with some context. You start the loop. That's pretty much it. And then you can sit and watch how well the loop is going. So I just let this run overnight. So this repository that I was showing you guys, so I worked on this last night. It only did a cool 110 commits. I was involved, in maybe like one commit, like maybe the first one. Everything after that, writing the readmes, documentation, tests, everything is being handled by Ralph. So why is this technique suddenly picking up and why are people talking about it? Is because we have access to some really ridiculous models right now, right? Like if you're using Opus to code right now, Opus is unhinged. Like you can do so much. If you think Opus is not good enough, I gave my app structure to Codex and I asked Codex to just keep working in a loop, and it did, right? If you're using Cursor, the great thing with Cursor is you can use any Cursor model. So Cursor has access to Codex. Cursor also has access to Composer. So if you're familiar with Cursor's Composer model, it works at like 300-400 tokens a second to generate code. It might make more mistakes, but it's a faster iteration loop for me to fix my mistakes. So I can put Composer in a loop where it can make mistakes, learn from its mistakes, and like keep patching, and it'll run super fast. So this kind of a setup allows you to do so much more. You can build your own system as well for this. The reason I suggested you can lead with this is because this does something that the Claude Code plugin does not do, which is memory management, which in my opinion is probably the most important part of this, because if you're not managing the context window properly, then all of the other stuff of like the agent running in a loop is nothing novel. Like you can do this on your own. The whole selling point here is how do you manage the context window with the greatest efficiency possible while creating that learning loop for your agent. And that's what Ralph is. Yeah, questions? Yes.
Would you do this with sub-agents?
Sub-agents, yeah.
Like in a different way, so.
Yeah. I mean, this is extendable, right? Like because you can spin up agents on the fly. Right now, I'm just assigning it to one agent that's working in a loop. Maybe you can just split it up and be like, hey, based on a to-do list, spin up no more than 5 agents. Right? One of the things that I can do to control it is, let me go to Ralph. Actually, Ralph task should have this. So I always have, is it in this or no? Usually I can also put how many iterations of this I want. Let me just open a different one. What did I build? This one should be okay. What's this and this? Yeah, so you can see like you can put like max iterations 100. So I only want this to run 100 times. So it can stop once it's done. You could also try to extend this and be like, hey, like spin up a Cursor sub-agent to only work on like this set of tasks, or split up the tasks by phases. The thing is that it's super malleable, but principally still the same. Like, how do I manage context windows? Cursor is working on sub-agents now as a feature as well, but if you ever used AMP, AMP allows you to spin up sub-agents. Like, you can just be like, hey, use 3 sub-agents to like do something for me. What this Ralph Wiggum system can allow you to do is you can even define what the sub-agent is doing and then like split out. Other questions? We're basically at the end of the presentation now. This was like added credits. So if you have questions, yeah.
Okay, just curious, like, is there a difference, like, in terms of the system design? If, let's say you allocated 3 agents,
Yeah.
or like 5 agents, like, when do you realize, like, in terms of like the number of sub-agents you
Yeah.
use, like, when does it break?
I mean, to be honest, in Ralph, it doesn't really make a difference because I'm spinning up a new agent like every 10 minutes anyway, right? Like, I think the sub-agent stuff becomes more important in parallelization of work, but I don't know how much that matters. Like, also because like you're adding an additional complexity where you expect the agent to figure out which tasks don't overlap, right? Because you don't want the same, like multiple agents working on the same files and then they're creating conflicting content, right? So, which is why like Ralph running in a loop is like a single agent running in a loop, which is fine. Like the usual reasons why people would do sub-agents was, hey, I'm trying to minimize time, right? Through parallelization of work. But if this is running in the background, like, I mean, I was playing Hades last night when this was going on, I wasn't really coding. My job was just to test the result at the end once it was done, like a few hours later. So, yeah. Any other questions about presentation or hackathons or like life in general? I also won at Hack&Roll like twice, like 10 years ago. So like, quick, if you need hackathon questions or anything, I'm happy to answer.
What do you win your hackathon with?
Oh, 10 years ago? I'm trying to think. So the first time, no, the second time we won, we built this like hardware device, which was, again, keep in mind, this is like 2015, 16 era, okay? Like tech is very different. But we wanted to be able to draw in 3D by like drawing in space. So what we did was we got 3 dustpans, like the sweeper dustpans. We put like 3 hooks and we hung a pin in the middle. So if you use the pin to move in space, those dustpans had cups attached to them. So those cups would move and each cup had an ultrasonic sensor underneath. So the distance to the ultrasonic sensors would change as you moved in 3D space. And each of those 3 sensors would give you an X, Y, and Z coordinate. And then you could use that with 3JS or something to draw in 3D. So the demo was literally, we bought $20 of like junk, like 3 dustpans, like, cupcake cups, string, and just put 3 sensors. That was it. It was pretty cool. Like it worked. Like, the whole point of like these demos is that it should work. Like, so, and it looked pretty, it was like this big. So it looked pretty cool. Yeah, that's a thing I built the last time I won a Hack&Roll. Yeah.
Sorry, just
Yeah.
like just curious on the CLI. Like,
Yeah.
because currently I'm using the process ID.
Yeah.
Let's say if you add, I don't know, a Claude Code equivalent.
Yeah.
But in a CLI format, like would there be like clashes with
No.
context?
No. I mean, Claude Code is its own thing, right? Like one of the interesting things that I don't know why more agents don't do this, and I'm trying to do this within Ralph now, is why can't you call other language models as a tool call? So let's say like Opus is working on something and it realizes things are hard. Can I just like tag team Codex in so the Codex can come and do it? So the good thing is that like AMP allows you to do it. On AMP, what you need to do is you can just say invoke the oracle. And what invoke the oracle would do is, let's say your main coding model was Opus. If you invoke the oracle, then GPT-5 would come in and then advise Opus on everything that it was doing wrong. And then Opus would be like, sorry sir, let me go and like build it for you. Right? So you could tag team it in. So but the thing is, because Codex is CLI based, like I literally have like a command in my notes, I'm pretty sure. Like I literally have this like orchestrate Codex as a tool that I want to like throw onto my Ralph Wiggum agent and see, can Ralph spin up Codex for tasks that it thinks are harder and then like work on it. Because I mean, again, if you have an OpenAI subscription, Codex is free, right? So you might as well use it. Yeah. Yes.
Sorry, question about like life, right?
Yeah.
Well, how do you use like Cookie.ai like to manage your life?
Oh, isn't that, I'll show you what Poke is. So Poke is this thing that these guys from Interaction built. And the good thing is that this runs on WhatsApp or iMessage, which is great because like that's where I spend most of my life, right? Like I'm like yapping to people or whatever. You can create integrations where like I can connect it to like Linear or Notion or whatever. So let's say I wanted to check what my to-dos are for work, because we use Linear for work. I'll be able to do it through text, right? And it can fetch that information and help me out. If I wanted to monitor my deployments or anything, I could connect Vercel. So now imagine I'm literally just on the bus, and I can like create a pull request. I tag Cursor. Cursor's agent like spins up a cloud agent and like makes a PR for me, and I didn't have to touch my laptop. Like that's just like kind of stupid things you can do, like through like just text messaging. But obviously you can also create integrations. So like, like as I mentioned, I have like my damn bus, right? Like the bus ride thing. So if I go to like iMessage, so like you even told me, like we were printing T-shirts for like Gemini's hackathon. I have like a VC meeting. Remember that there's an NUS Hackers event today because it can read my calendar and stuff. Like, I can be like, what time is the bus coming near NUS School of Computing? It can like go figure out using my tool what the bus might look like, what the bus stop is or whatever, right? So this is very useful. Even like for my emails, I had like less than 20 spots left for the Gemini hackathon and I got 200 emails. Like I have no time or bandwidth to read all 200 emails. So it was summarizing for me who's like interesting, who's good, so I can like approve them for the hackathon. So that's why like this starts becoming useful. My girlfriend uses this with like 3 or 4 email accounts. Like so like 3 emails plus the calendar plus like Notion and everything. So her life runs on this, which makes sense. But again, as I showed you, that like the integration limits are like pretty much limitless, because if you don't see an integration you like, you just create an integration, which is an MCP, and you don't even need to code the MCP yourself. Like when I did the bus one, I used Manus, and I'm not even kidding. I could show you the thing. Where's the bus? Was it this one? It probably was this one. Yeah, there's like bus MCP was done by Manus, and then it connected to my GitHub and Vercel and just deployed it. So I never even opened code. Like everything was done in Manus. I just got a link at the end of it. They're like, hey, like here's the, like, I worked on the endpoint and stuff and it was testing for me. And then once it was done, it told me, here's your endpoint, just give it to Poke, which is what I did. And that was it. Here. So IT stop right by School of Computing. Here are the buses. Cool, right? So it's that's what I mean by extendable. So if I wanted to like track the news or like do something like random shit, I can extend the app in whichever direction I want. But the bigger story here is that all these apps are now going in the direction of them becoming personal apps, right? Where your decision is, can I just build it myself? Or is there a layer on an existing app that I can extend to do things that I want? Like maybe you want to track, I don't know, something else, like I'm looking for buses. Maybe you're looking for like sneaker drops or like restaurant reservations or whatever. Like build your own automation, right? Or you get like Cursor or someone to like build it for you, and you just plug and play all these random things together. Like maybe you want to monitor like Discord notifications, but also Telegram or whatever. Like daisy chaining, a lot of this stuff is pretty easy, but it might also just be your use case. Like my girlfriend, she was building some like telemetry tool to like, she has this chat app for personal finance. And because she has semi-structured conversations as part of the chat where some conversation segments are super structured and predefined and others are open-ended, it's very hard to track and do evals for those kind of conversations. So obviously there's no telemetry system available. So she just built her own telemetry system, right? Could you use something like open telemetry? You could, but like again, like you have to like do more work and like build stuff on top and figure this out. But she just asked Cursor and Cursor built it for her, and now she's having a good time with it. So anyway, that was like how poke and stuff works in the ladder scheme. Any other questions? Yes.
Like, this is a bit of a distant concern, but
Yeah.
in something like a corporate context, I imagine maybe there might be sensitive data or even code itself might be considered sensitive.
Yeah.
Would there be any like restrictions on using outside tools?
Like these AI tools?
Yeah.
Yeah, I mean, but there's a very clear thing you can do here. So if you go to the Cursor settings, right? So one of the things they ask you front and center usually is, do you want them to use your data to train? Where is it usually at? Was it in rules? Basically, there's like a setting that allows you to tell them that like don't use my data for training, which is useful because I don't want it to take my data and use for training. Claude Code has a setting as well, so your code doesn't get into the training set. Privacy mode, yeah. So your code data will not be trained or used to improve the product. Code may be stored to provide features such as background agent. So I'm running on privacy mode, so no training, right? This is useful, but if I was on shared data, my code would be going to the public. The rest of it, I mean, is like more or less the same. If you want to run your apps in a secure environment, you'll still have to use some combination of like, AWS or like Azure or like Google Cloud or something. If you're using a public AI API, like let's say I use Gemini, I can't use the API key from Gemini because that's a public endpoint. So I will have to use Google Cloud's Vertex and Gemini served over Vertex. So then that tunnel is private. So whatever requests are being sent on either side are encrypted. But otherwise more or less the same. Last questions before we call it? Yes.
What do you do full time?
What do I do full time? As I mentioned earlier, I have a startup called Neum. We are building the data layer for electronics manufacturing. So the guys who like build your laptops, phones, or whatever, right? The process is super manual because you start with figuring out all the components that will be part of your device. Each component has what we call data sheets, a few hundred pages, could be a few thousand pages, which illustrate everything from the dimensions of the component to the electronic specifications, all these things. Then, deeper down the line, you try to figure out, do all these components work with each other? Yes or no? If they work with each other, are these components available? If everything is a yes, how do you place them on the board? Because my phone can only be this big, right? My phone is not this big. So things must fit in like the space that's available. All of these things are human right now. All of these things. So you can imagine if like, someone is designing the library for all these components and misses a pin or messes up a dimension, you will only find out after you've committed to using it. But the problem is like these things can cost them a few $100 million like a year. So it's pretty significant. Like even like these small problems compound pretty quickly. So what we're doing is we're building tools to sanitize and clean a lot of this data at the very beginning, and then present this in a way that these companies can use it. So they can prevent a lot of problems early. But obviously, this is where like some of the other stuff comes in. So when I mentioned that I was building other garbage. Like the other garbage I was building was for this. Like this library was, so a lot of the industry uses something like KiCad to like design electronic schematics, but I wanted to find a TypeScript way of doing it. So now I can have a AI interface where I use natural language that, hey, build me a circuit or a schematic for like a guitar pedal or like some crap, and it can convert that to make it a schematic diagram and with like, what the position of the components are and everything. So for the enterprise customer, this will be like voodoo magic, but for us, it's TypeScript, right? Um, and like it also has an MCP server, so I like tested this within Claude, where I can ask Claude to like make a schematic, and it'll just use all of this and like build schematics for me, which is cool. Because none of these things are programmatic right now. So, but you won't believe me when I say that this repository was built by Ralph in a loop over like 2 hours. Like I was not involved. And this works. So yeah, welcome to software engineering in 2026. Yes. I think we're good for time as well. Yeah. Awesome.
Yeah, if there are no questions, then we can give him a huge round of applause.
Thanks all. If you guys want the deck, I don't know why you would, but if you do, it's at nus-cursor-workshop.vercel.app. There are some resources and stuff you can follow. Might be useful. Cool.
And so
Yeah.
stop the recording.